Welcome to today's webinar brought to you by Cube, Prophecy, Materialize, and Couchbase. I'm Stephen Fegg, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled The Future of Data Engineering, AI, Automation, and the Cloud. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we're very excited to have with us David Jayatilaka, VP of AI at Cube, Mei Long, founding member product at Prophecy, Seth Wiseman, Director of Field Engineering at Materialize, and Matthew Groves, DevRel Engineer at Couchbase. I'm going to let each speaker introduce themselves and give a quick presentation on their approach to this topic, and then we're going to have a group discussion. So, without further ado, I'm going to pass the event over to David to get us started. Welcome to the broadcast, David.
Thanks for having me, Stephen. Great to be here. Firstly, a little bit about me. So I'm David, VP of AI at Cube. I've joined about 3 months ago now. Before that, I was a founder at a company called Delphi Labs, and what we built was an AI application that allowed users to query their company data built on top of semantic layers like Cube, and that's how we ended up joining Cube, who are one of our very good partners. So let me give you a little brief overview of Cube and how we are involved in this space. So these are like very well-known problems by data folks. Data stack complexity. We've all seen the diagrams of all the different data tools that exist, and many tools stitched together, lots of complexity, lots of integration points to manage. Proliferation of siloed data. This is still a really big problem that people report, and many disconnected data apps. And also, everyone's business logic is stored in the application of choice, whether that's a BI tool, whether that's Salesforce, whatever it is. We have these inconsistent and many business definitions. So this is the problem space. And Cube aims to solve this by providing our universal semantic layer, which provides a data modeling layer where you can define how your data relates to each other, how it joins together, and what it means. RBAC with access control, caching to save money and increase performance, and multiple APIs, including our new AI API, which I have launched since joining Cube. And with Cube, we help you provide a single source of truth with consistent metrics across all different consumption methods, and govern and enforce these fine-grained controls in Cube and allow multiple applications to use it, and optimize using the cache and the pre-aggregations that I described just before. And so we benefit many different people in your organization, from your technical decision makers who are caring about budget and operational efficiency, data engineers. Cube is code first, and so we enable version control and that level of consistency over data definitions. Data analysts, so we've recently launched our catalog, which allows data analysts and business users to understand what data exists and the provenance and lineage of that data. And also, we also launched our AI assistant, which allows business users to ask data questions and get quick and easy answers with the safety of the semantic layer. And this is an example of a company that we've really helped, who previously they had a difficult situation with their BI solution. It was inflexible, the analysis was slow, and they had very little control over features. Because they now use Cube, they get our speed, they get customizability, and can deliver fine-grained control as well. And just recently, we got ranked as a leader by GigaOM in the semantic layer space. So that's me. I'll hand over to May.
Hello, everybody. Welcome. And my name is May May Long, and I am one of the founding members at Prophecy. I've been doing data things for over 20 years, working with projects such as Spark, Kafka, Hadoop, Kubernetes, and more. So really excited to be here to speaking with you all. And just want to give you a little introduction on what we're doing with AI and machine learning at Prophecy. So we are a data transformation co-pilot company. And what that means, I'm going to explain in the next few slides here. So basically what we're trying to do is bring all data players together into the same arena. What that means is that if we see there's quite a bit of a disconnect between data engineers, data analysts, data scientists, those teams tend to work in their own little area, and they don't tend to share or communicate or work together very well. And there's various reasons for that. Some of them can be solved easily, some of them cannot. And what we're trying to do is create a product that everybody can use and be very productive on their data. And before we dive into what exactly we do with Copilot, data Copilot transformation, what that means is that let's talk about some of the things that we're trying to solve. So for all of you out there, hopefully you kind of have, can kind of sympathize with some of the pains that users are going through, especially enterprise users. So if you have legacy ETL tools such as Ab Initio, DataStage or Informatica or Alteryx or things like that, you might know the pains of proprietary tools that offers a really nice and easy use interface. However, once you start moving to the cloud, you start realizing some of the things is a little difficult to utilize because all of the stuff is locked in and proprietary, and also things might go to the cloud and not scale, right? So those are the type of pains that users really have to deal with. Also, they don't integrate with the cloud services very well. Where cloud platforms such as Spark and other things that hosted it in the cloud, and what it solves some of the problems that traditional tools might have, but introduces a set of new problems. That means with flexibility and with transparency, it also comes a great amount of maintenance knowledge that's required to maintain those. And so you have to have deep understanding of distributed systems to make them work. I remember many years ago when I started working with Hadoop in, I think, 2011, one of the person that described the system is like, it says, because spaceship with lots of buttons, and you have to make sure every button is put in the right place for everything to work really well. So we want to make sure that that's a really powerful thing, but is not really for everybody to use effectively, especially for data consumers or business users that are out there. So this is what we're trying to do, is making sure that folks that get out of the box be able to use a nice and easy to utilize UI where they can just drag and drop the things. Okay, here are the data that's coming from whether it's Delta Lake, whether it's OLTP, or whether it's Salesforce, whatever it may be. Users can just drag and drop various what we call gems, which is various sources, transformations, and also targets, so that they can really design these things visually, yet is not locked into them into a proprietary space where they have no visibility into their code. So really enable all the users to be very productive in the same area, but also when they translate everything down to whether it's Databricks, Snowflake, whatever it may be that they're using, is the native code that's run on there, which is Spark code or SQL. So they have full visibility into what the code is going to look like, and also all that resides in their own Git account. And we really want to make sure that folks are liberated from their traditional proprietary formats and be able to own all the code that they have. So that's the problem that we're trying to solve. Now introducing Copilot. So the Copilot that we're trying to accomplish is that there's a lot of very cool use cases, such as we know a lot of metadata. We work with data. Our users work with their data. There can be a lot of knowledge that comes with that data. So traditionally, if you think about ETL, and really, if any of you all have built ETL projects before, it's incredibly painful. Is that you have to do data mapping, you have to make sure everything is manually mashed up properly, and all of that stuff can create a lot of pain for users. So the Copilot is to make sure that all that stuff is automated and make sure that every single user is very productive, whether you're on Spark or a SQL engine underneath everything. So this kind of format is really provides a lot of value to some of our large enterprise users. As you can see, you might recognize some of the logos on here. And that's because it really brings their data players into one place, onto one UI. And so that if folks decide to switch teams or do other things, they have a very familiar interface that they're working with, but underneath everything is all open to them and transparent to them as well. So just to summarize really quick, it's really important for our tool to be intuitive and very smart, and also is open and extend to other things if people choose to do so, and integrates with other platforms such as Databricks, Snowflake, whatever it may be that you're using. It integrates with them also very well. So that's all for my time today, and I'm going to make sure. Let's see, Seth, are you there?
Yeah, thank you. Hi, everyone. My name is Seth. I am the Director of Field Engineering at Materialize. So I get to work with our customers on some of their most interesting data problems. I've been here for a few years now. Prior to this, helped create and bring to market an open source stream processor called Apache Flink. So I've been in the data space for a very long time. Very excited to be here today. Broadly, I have the belief that businesses that are able to act on their data more quickly are going to outpace their competition, right? If you can preempt your customers' needs, if you can solve a problem before they even know it occurs, they're going to be happy. They're going to want to work with you over the competition. The problem is this has historically been a very challenging problem to solve. We tend to see people approach this from one of a number of directions. The first is working against an OLTP database directly, right? Your most important data, your freshest data lives in that central database that backs your main application. And for a small organization getting off the ground, it makes a lot of sense to work right there. But the issue is that database is doing a lot of really important work, right? It's serving that main service. If you take it offline, your business is off. And so you might move it to a read replica, but even that might not be fast enough because we tend to be running these more complex analytic style queries that a database like Postgres or MySQL are just not built to handle. You got to work with your DBA. It's a lot of work. And so people very quickly outgrow that and move into one of a number of directions. So some people try and solve their real-time data challenges using their cloud data warehouse. And on paper, this can make a lot of sense. You go, hey, look, my data is already there. I know how to use it. It's SQL, it's cloud native, it's all these wonderful things, except you start to refresh your models more quickly and your costs get out of control. Even if you're refreshing this thing in a hot loop, your latencies might not be good enough, right? This platform was built from the ground up to process potentially large amounts of historic data, not to keep things always up to date or serve web scale traffic directly. The other pattern we see people approach is using a specialized stream processor, something like a Flink, a K-Streams, a Kafka. And this can work, but it requires a lot of specialized engineering talent. You need to train your team or hire a specialized team to build these applications. It removes the development one step further away from the business. And even with that specialized team in place, it can often take a lot of time to bring something into production. And so Materialize is meant to be an operational data warehouse. And I'll dive into what that means in a moment. But the idea is, hey, look, we want the experience of a cloud data warehouse that's separate compute and storage, that easy-to-use SQL interface, isolated compute, with all the benefits of real-time data. And so broadly, I view the data world as being into two categories. There's analytic data and operational. Analytic data is what traditional cloud data warehouses, think Snowflake, Redshift, Databricks, are really good at doing today. Right? We process some amount of historic data to make predictions about the future. This is where our data-driven decisions live. In sort of a hand-wavy, wildly overgeneralized way, we can say the output of these data products often involve people sitting in a room and talking about it, right? Like I look at last month's sales data, we sit down and talk about it and decide how to deploy our marketing spend next month. Operational data is that which is really valuable in the moment. Something where when you know a piece of information, you can immediately take an action. So fraud detection is sort of the canonical example here. When you detect fraud, there's no question of what to do next. We don't need to set up a meeting and talk about it. We need to shut down the account. We need to alert the person. Or maybe we're looking at data coming out of a manufacturing plant. If you see something is broken, again, there's no question of what we do. You send somebody out there to go fix it. And what we found is that this operational data, the data that we can immediately take action on, often really benefits from knowing that information sooner than later. And so Materialize is looking to solve this problem by taking that existing cloud data warehouse feel, something that your team is very familiar with, something that you're able to be productive with, but build it on a new foundation. We're going to do all of the work on write. So traditionally, when you query a database, it is going to execute some SQL. It's going to do some stuff. And if you execute that query again, it's going to have to reprocess all of that data, redo that work, even if very little changed. In Materialize, we're going to do that work on write. So as the underlying data changes, we're going to proactively keep your results always up to date. And importantly, only do work proportional to the diff. Only do work and reprocess a row if it actually changed. But beyond keeping it up to date, we also want to ensure that it's correct. And so databases, data systems can have different levels of correctness and consistency. And by default, Materialize is going to offer what's called strict serializability. It's the highest level of correctness and consistency you can get in a data system. And that's really important if you're working with, say, financial transactions. You can literally do banking transfers and Materialize. But even if you're not, even if that level of correctness is not so important to you, what I've seen in practice is most people learn SQL on a database like a local Postgres installation, like a local SQLite, that offers strict serializability by default. And it means it matches your intuition of how the system is going to behave, making it easier to learn and pick up. And then broadly, right, it's meant to sit in your existing stack. Materialize is Postgres wire compatible, which means it already integrates with all of your existing tooling, pull data from where you need it, send it where you need it. And it unlocks the ability to do solve these operational data challenges without needing, again, that specialized team, that specialized skill set. Allows you to be productive right away. Very excited to be here today, and I will pass it over to Matthew.
Yeah, well, here to talk about Couchbase a little bit. We are a cloud database for building modern applications, including AI-powered applications. So that's kind of our first slide. The next slide there is just kind of the three main points, the three pieces of value we bring to the table. So we're a distributed document database. Some people say NoSQL, but we actually support SQL for our JSON data, so we call it SQL++. Couchbase is great for building global applications, and one of the ways we help with performance is a lot of our reads and writes, replication and synchronization all happen in memory. And synchronization replication also helps with our cloud-to-edge situation. If we're using a mobile database, it provides offline first capabilities on your device and IoT. So the next slide here is about architecture. And so oftentimes, as a developer, as a development team, we'll start out with maybe a single database for building a new offering. And as we need more functionality, we add on those kind of point solutions, those purpose-built databases. So I'll start with maybe Postgres, and then I'll add on, I need Redis for caching. I need Elastic for text search. And then before you know it, you have this condition called data sprawl. And I think this was brought up earlier is a comment about it. What was it called? It was called data stack complexity, as David called it. So this is what's going to happen. It's not only do you have all these different databases that you have to patch and upgrade and manage and learn SDKs for, but you have that nest of lines up there, the integrations, the pipelines between all these systems and your application. And this can increase costs, can increase training, increase number of licenses you need to have, increase integration work you need to do. So our approach here, our architectural approach, the next slide here for Couchbase, is that we have a database platform that includes a lot of these services already. So if you're in a situation like that where you have data sprawl, Couchbase can help you reduce it. And if you're in a situation where you're just starting out, Couchbase can help you avoid that. So in our database, of course, our bread and butter is key value access, JSON data, and cache. But we've added, and since I've been here, I've been at Couchbase for 9 years now. We've added SQL queries. We've added full text search. Recently, we've launched vector search. We have graph traversals, time series. All these things are available in Couchbase to support different access patterns, and the performance foundation to support all of those patterns as well. And it can be deployed to, as I mentioned, a cloud database. So Couchbase Capella is our DBaaS platform, but of course it can also be a managed installation. So you can just download Couchbase Server, deploy it to any cloud you want, to edge situations, even to your own on-prem data center. The next slide here is just a top-level view of why companies go with Couchbase. Performance is kind of a big one. We're memory first, right? But flexibility there. So I keep mentioning all the different data access options. JSON data can represent different flexible types of data. Mobile and IoT, we have really great offering with Couchbase Lite that allows you to build applications that are offline first that will work even when you're in remote areas or situations when you have no connection, and automatically sync. And then kind of the main thing is simplify, right? So if you have all these different point solutions, you can use Couchbase instead, or you can reduce those point solutions to save a little bit of money as well, and operational costs on that front. So the next one is just a few examples of some use cases some of our customers are very proud of that are accomplishing different things using Couchbase. So LinkedIn is one of my favorites to show because it's such a huge one everyone uses pretty much every day, being used for caching there. And maybe we'll talk about Domino's a little bit when we get to the roundtable. It's, I think, the most interesting use case for this discussion. The next one is just some stats about our customers and what they're accomplishing with Couchbase. Sort of high performance, high volume, huge names that you've heard of and you've used probably every day. And just finally, one more slide to brag on our customers because they're the ones that are doing the really great work building on top of Couchbase, doing it in all these different industries, all these different use cases, all these different verticals. And I'm sure there's probably at least a handful of icons there that you're using day to day, if not using right this minute. So we think you can do some really cool stuff with Couchbase. And that's what I have for today. So you can check it out at couchbase.com. And I'm going to hand it back to Stephen to lead us into the roundtable.
Fantastic. Thanks so much, Matt. We're going to bring everyone back into the scene here and dive into our group discussion questions. So, David, I'm going to pass this first question to you. And the first question is, how is real-time data processing reshaping the practice of data engineering?
Yeah, so I think one of the ways that I see this reshaping things is that when we think about batch, which is what we have alongside streaming in real time, there's always these kind of cadence of, oh, we have to run this job, and maybe it's every hour, maybe it's every 5 minutes, but you always have to run this job, and then things are, somewhat up to date. And it actually overcomplicates architecture because of that, like the way you have to have orchestration and the way you have to have lots of other facilities in a batch processing environment. Whereas with streaming in real time, I feel like in many ways it's simpler because the data is being piped and processed as and when it arrives. You're not having to do those scheduled batch processes. There is also the ability to have like triggers and customer experiences that are triggered by these real-time events that are affecting what they see in applications, which I think is really interesting as well, and which was really, really difficult with batch. It always involved a lot of difficult caching and other steps in order to use batch data for that kind of situation, and it was very difficult. Whereas with streaming, it's not so difficult.
Sure. May, what are you seeing in this space with regard to real-time data needs and how that's impacting data engineering, if it is? You know what, May? I think you might still be on mute. If you want to just check your...
Yeah, sorry about that. So I do think it impacts data engineering quite a bit because I think it forces people to rethink data architecture in general. I think streaming is such a different way to think of data that's very different from traditional way of doing data engineering. So people not only, I think David made a very good point where streaming is more of a declarative way of doing things, so that you kind of skip the orchestration complexity in some ways, but also it introduces really interesting features such as, when you're streaming, how do you do joins? When you do joins, when the data is streaming, how do you do windowing? And when you do windowing, how do you do ranking? And all of these things, I think it introduces really, really interesting concepts into the data architecture. And I think also streaming is not easy. Streaming is actually quite complicated. So if you see like all of these tools, especially I think Seth mentions Flink and those type of tools, it existed for a long time, for a while, and it took a lot of smart people to understand how to persist the state so that you can recover from various failures, how to do exactly one's processing. All of those things is a lot of smart people put a lot of I guess brain power into making this possible. And I think it definitely impacts data engineering quite a bit because it does require folks to rethink what the data architecture can be in the future. Yeah.
Understood. Seth, real time's obviously
Yeah.
near and dear to your hearts at Materialize. Curious, are you seeing more demand for this? Is it more front and center in people's minds?
I think so. I think fundamentally, real time moves data engineering from a cost center to a profit center within an organization, right? If you are building out a quarterly report, which is, I'd argue, important, but maybe not something the business needs day to day to keep the lights on. It's viewed as a nice to have. But when data is directly powering applications, when your customers are interacting and gaining value from it, it's now suddenly an important part of your application stack. It is something that is driving revenue. And it means that we're no longer off to the side of the engineering team, but a core part of the engineering team within an organization, a core part of the product that the team is selling, that the business is building on top of. And I think we're now getting to a place where, for a long time, real time was incredibly difficult for all the reasons that May just mentioned. We're now starting to get tools that make this approachable to people that don't have the specialized skill set. And organizations, we are seeing a lot of teams that go, hey, it was really amazing I could do this once a day, but now that I have it always up to date, it can be a part of this application. I want to drive more data into my core business processes, into my core application stack.
Understood. That's a great point. Matt, curious what you're seeing at Couchbase.
Yeah, so a lot of what David and Seth is saying is something that Couchbase is definitely building into our database, right? So the importance of speeding up the process of getting those actionable insights, kind of as Seth was mentioning there. Just as an example, one of our customers, Domino's Pizza, they have a really cool use case where they're using our analytics, which is kind of like a translytical operational analytics situation, similar benefits to what Seth's doing with Materialize. But they're able to adjust their marketing promotions on the same day based on the outcome of a football game, for instance. So not just the same day, but within minutes, right? And another thing I'm seeing, of course, is the batch processing is still prevalent in the industry, for better or for worse, but definitely the switch from batch to streaming, right? So again, in Couchbase, our analytical offering is immediately getting updated based on operational data, so it can be queried right away. So in seconds or less instead of overnight loading of CSV files. And then, of course, the last thing, which I think is affecting everyone, is being able to allocate resources in the cloud in a more flexible, faster way to get those necessary resources makes data engineering tasks. That's one less hurdle we have to deal with.
Understood. Moving on to our next question, David, moving back to you. How prominent are cloud native platforms and tools amongst your customers?
I mean, they're hugely prominent. Like the number of our, and if you think about like the big ones being like Snowflake, Databricks, AWS, and using Redshift, GCP and BigQuery, like a huge percentage of our customers use those systems. And not only that, they're using other services that those cloud providers offer too, including, AI as well. Those providers are offering their own models, and our customers are interested in using those as well. So, yeah, the vast majority of our customers are using these cloud services. Whether they're also using some on-prem as well still, yeah, maybe some of the time, but mostly it's on cloud.
May, is that what you're seeing as well?
Yeah, and absolutely. I think by default, a lot of the folks you would say were cloud native, and what cloud native means might be vary for different people. So, so obviously we run on Kubernetes. I'm sure a lot of the folks on here, their backend is Kubernetes as well. So, so basically, I think the idea of being able to run it in any cloud, and also if you do have, we deal with a lot of really large customers that are in banking and in healthcare, which have some regulations where certain things just cannot be public. So, that being said, whether it's in a private VPC or some kind of closed off environment, I think just having kind of an orchestration, kind of a microservice architecture allows them to be somewhat cloud native, even if they're not on the public cloud. That being said, I think with today's topic, where it's very much around AI, we do see users, whether they're on Bedrock or they're on Llama or they're on OpenAI. Everybody has some form of LLM in their organization today. So you kind of have to, unless you're doing your own LLMs, which I don't think any customers are really doing that natively. But I think being cloud native is kind of required for you to be able to use these foundational models. Yeah.
Understood. That is ambitious, the build your own LLM approach. I'm sure maybe somewhere out there, but in any case, Seth, is this what you're seeing? Maybe I should just ask out loud, Does anyone not have customers and prospects that really aren't mainly using cloud native platforms and tools, or the inverse?
The only time I feel like it comes up at this point is, large bank legacy infrastructure. There's just practical economic reasons why migrating is difficult, but I don't think I've ever seen a company that was founded in the last 10 years that said, we chose to go on-prem and we chose to run everything ourselves.
Yeah, it'd kind of be like, going with the horse and buggy instead of getting a car to a certain extent. Why don't we pivot? No, please.
Sorry. No, I did not mean to cut you off.
I was just going to say, it's like, it seems to be like degrees of how much they want us to be on their cloud environment versus ours. That's really the question. It's like, what percentage of the application is it like full SaaS, or is it fully in their VPC? Do they want to bring their own cloud? And like, we kind of try and support all of those situations and different gradients of them. But that's the question. It's not whether it's not cloud or not.
Yeah, issues within the actual cloud or clouds if they're doing a multi-cloud approach. So why don't we pivot to our next question? And Matt, I'll let you start off fresh with this one. How are advancements in AI impacting the role of data engineering? Big topic.
Yeah, I mean, how much time do we have? But I think one of the obvious ways is that AI, things like Copilot and ChatGPT and so on, it can really help to automate some of the more routine, repetitive tasks for anyone writing code. I'm hearing a lot of noise here. I don't know if anyone else can hear that. Okay. They can really help to build those tasks out. And then, of course, some of the more advanced things that AI can help do is maybe the automated detection of errors, anomalies, data inconsistencies, and possibly even scanning for PII, which might be interesting use case for AI. But one of the things that I think is the most forward-looking at Couchbase, we're calling it the idea of adaptive applications, and these are applications that customize the experience for users without the user having to front load all their preferences. So, for instance, a analytics or a columnar query in Couchbase can pull together a user's location, their activity, what they're doing, any profile information they have, which Couchbase does a lot of user profile storage anyway, any other ambient information, and can create customized content, reports, emails, things like that. So I think that is the more interesting way that we're going, and that's a little bit more cutting edge. So we haven't seen a lot of that hit the market just yet. But we're calling it adaptive applications. We don't know if that's going to be the official name for it once the buzzwords, the dust settles on the buzzwords. But I think that's where we're going with that.
I like the sound of that. I'm always up for new buzzwords. So David, given your focus on semantic data layer, enabling better accuracy, through AI, what are your thoughts on this question? How it's impacting data engineering? Is it going to replace a lot of key components of data engineering at some point?
So I kind of got like a reverse perspective on this, because you see a lot of people kind of post memes on LinkedIn about, oh, everyone wants AI, but their data engineering is in a bad state, and you're building AI on top of shaky foundations. And my perspective is, actually, I think this is the incentive. People need to be incentivized to invest in things. And I think the executives out there, they want AI. They want AI in their customer products. They want AI to use for themselves. And we see this at Cube, they want these things. And they're willing to then say, well, data engineering team, this is what you're going to build towards. And I think it's up to those data engineering teams to say, we need to clean house on this part of the data model and the pipelines that flow into it, in order to allow you to have AI for our customers or for yourselves on this data. And so I think it's like a business case for data engineers to invest in what they've got and their pipelines and their quality, and then build things like semantic layers with and then AI on top of those. So I think that for me, it's it's the carrot that will drive data engineering to better places.
AI readiness angle. Yeah. May, is this what you're seeing as well?
Absolutely, I agree with David, and I think this is actually very close to our hearts, because we are in the space of ETL and making sure everybody can use the tool to get to transform their data. So I think the part of AI that's working really well in general in our industry is as far as I can tell, the GitHub, the Copilot is doing very well. I think a lot of the developers use it, and we actually started our AI journey quite early. I mean, 2 or 3 years ago we started it, and so with foundational models. And I think the thing that we really want to focus on, and that's really important to us, is being able to provide the Copilot experience to data folks, right? So not just for developers for GitHub, but also for data folks, whether you're an analyst or engineer or data scientist, we provide that Copilot experience to these folks as well. And that means what David had mentioned, that there's a lot of mundane tasks that's associated with data engineering. You're manually mapping things. You're trying to discover the columns, what there are. So a lot of these things can be automated. One of the things that we do, I think is kind of cool, is the declarative way of doing things, where you have, what your data is supposed to look like at the end. And then we use our model to populate everything in between for you, right? So it's not just the prompt engineering where you type in, here's the question I want to answer, and here's the pipeline that we have as well. But also, here's the schema that I want to achieve. Now AI, go build everything for me, right? So I think that's something that's really neat, that's available right now. So another thing is for analysts is to be able to just ask questions and being interactive with the platform as well. So I think I really believe Copilot is for data engineering is the way to go. So I think that's from our perspective, that's what it is. Yeah.
Understood. And it sounds like that really democratizes access to the data to be able to innovate with that, which of course, everybody's looking for more data and more access to it. So that makes perfect sense. Seth, would love your thoughts on this question. How is AI impacting data engineering?
Yeah, I think there's sort of I'm mixed on this. I don't know that I have a full view, because on the one hand, I do agree. Like, look, I have this question I want to ask of my data. I'm not exactly sure how to express that. You think of some of these LLMs as being very advanced autocomplete, to not to negate the level of complexity behind them, but they help me get my thoughts out in a way the computer can understand, and that seems very valuable, right? We've had people say, use an LLM to write SQL for our system that hallucinated a function that didn't exist. And their response wasn't, the LLM got it wrong. It was, why isn't this function working? The LLM told me it's supposed to work just this way. But then, and I think that'll get better. Like, I believe that the industry will evolve, and that is going to be a very useful tool to people developing. But then maybe my other position is, I was at a Snowflake Summit a handful of weeks ago. And you go and you watch the keynotes and you hear some of the talks, and AI is what everyone's talking about. And then I was at our booth for a week, and I had nearly 1,000 conversations with different people. And I don't think a single person asked me about AI. Like, people day to day are still focused very much on moving their data from A to B, transforming it in specific ways, understanding how they're going to surface it to people, not just how do you write the SQL, but like literally how do I get application A to consume data out of application B. And so I think there's still a lot of growing in the industry for us to determine, what does AI look like in the long term? How are people going to be using it in 5 years and 10 years? It's probably not going to look anything like we're doing today.
I think that's a really valid point. Well, I'm not going to say we all remember, but I think we probably all do, back in the 90s, when the advent of the internet, I don't think anyone could really anticipate what things look like today as far as internet and internet-based technologies. So probably the beginning of a longer cycle. In any case, why don't we pivot to another question? Matt, what are some data governance and privacy practices that all data teams should be doing to ensure trust and compliance?
Yeah, so I think there's a lot of legal implications here, and regulations that need to be followed. I'm not a lawyer, so I won't go into that kind of stuff. But from my point of view, data engineering point of view, developer point of view, a team building software point of view, I think you really need to take stock of the inventory of where you're putting your data and where your data is moving through. How many different tools do you have that the same data is stored in, right? And the bigger that sprawl, that data sprawl, as I call it, or data stack complexity, as David called it, the more surface area you have for non-compliance and for stale data and for attack. And Seth mentioned hallucination of an LLM for SQL queries, and one of the ways to alleviate that is through the RAG pattern. Send some relevant information to the LLM, so it's not just going off its own possibly very out-of-date model, but you can give it more accurate, more relevant, more up-to-date information. But that's difficult to do if your data is spread out amongst multiple places, could be out of date, and may not be relevant, could lead to just as bad hallucinations, if not worse. So, I think, what can you do to reduce that overall inventory of different systems where you're holding potentially duplicate or outdated copies of your data? So that's probably where I would start with governance, and I think privacy will be a side benefit of reducing that.
Understood. David, what would your recommendations be?
Yeah, so one of the things that Matthew just talked about how there's all these different access points. I think that's such a problem. Like, when you've got a data warehouse, when you've got S3, when you've got the applications themselves which are acting as data stores, because if you think about what a CRM is, it's kind of like a very thick wrapper around a database. And you've got all these places where people can access data. They're in different languages, they're in different formats, and it's almost impossible to guarantee security when it's like that. And this is one of the things, When people think about semantic layers, they think about ease of access, governance of definition, the APIs. But one of the things I think that people don't think about so much is security. One of the great joys of it is that you can have a semantic layer, like a universal semantic layer like Cube, which sits across many, many different data sources and on top of an abstraction on top of your main data stores. And because of that, people aren't just accessing these data stores directly. They're accessing the data they need in an as highly aggregated a form as possible. And that prevents these kinds of situations where people are having security breaches. For example, what happened with Snowflake earlier, just before the conference, if people were accessing data through a semantic layer, that wouldn't happen because it's just not possible. You don't have the flexibility in query pattern to be able to do what happened there. It's the fact that people were having credentials directly to access that data warehouse. That's a big part of why that happened.
Understood. May, what would your best practices or recommendations be in terms of improving data governance and security practices for data engineering?
I would recommend for folks to set a standard and really follow that standard. I think that's really important because I think what I've seen at organizations is that before the architect or a certain team set the standard and best practices, you have people go out and build maybe hundreds and thousands of Lambda functions. I don't know how you're supposed to make sure those are safe. I'm not sure. But so I think it's really important for, when we build what we Prophecy is to make sure that things are customizable and also shareable in a very secure way. And so basically what that means is a certain team, when they build a piece of code, a transformation code, it needs to be passed, make sure that this is the type of code that can be introduced to production. And anybody here, I would think, have built something that that works really well locally, put it into production, something breaks. And that's just the way engineering works these days. So I think what we really need to do is set the standard for a certain team to be able to deploy these standards safely, and also making sure that particular piece of code is being shared responsibly among different teams. I think that's really important across all data practitioners, and I don't see that being practiced very frequently. People start still doing silos, but I would really love to see teams move to that way where everybody have a standard together. Yeah.
Understood. Seth, how about you? Would love your thoughts on this.
I think the most important, maybe only thing you can really do is have a security practice from day one. I have never seen an organization retrofit security on top of an existing system successfully. Maybe they get there after years and years of headache, but it's never the smooth process that people expect it to be. But if you show up on day one and say, I have this data, this is the security guideline, this is the rules and process by which you can access it, and that is set up before a single user or single application is able to consume that data, then you can feel pretty good about it. And that doesn't mean it's going to be perfect. It doesn't mean things aren't going to evolve. But anyone that thinks that they are going to get something up quick and dirty and then go back later and add proper security, I just think is fooling themselves. It is tremendously more work than anyone ever anticipates.
Security first approach. Matt, is that what you're seeing as well?
We're talking about governance and privacy still, right? So yeah, certainly, security is something that you have to think about from the beginning. I definitely agree with that. Compliance is certainly important when you talk about regulation, like where am I going to store this data? What data center? And, back to the question about cloud, I think that's one of the driving forces with, on-prem as well for certain organizations is, we need to have complete control of our data. But just because you have complete control doesn't mean you have a handle on security either. So, I kind of think that's what I'm seeing mostly when it comes to databases. Yeah.
Understood. Thanks, Matt. Okay, I think we have time for maybe one more question, maybe one or two. David, I'm going to pass this to you. Data architecture is a major part of data engineering, and we continue to see new developments in this area. There are a variety of different modern data architecture approaches for organizations out there to consider. What do you feel organizations should keep in mind as they're considering new approaches?
I think one of the big things that I see, and this is based on like one of the big complaints out there that we talked about earlier, is like data stack complexity. I think whatever stack they choose, it needs to be something that they can easily manage, that they can manage the interfaces between the different parts of the architecture well, that there's not too much for them to look after. Because I think, like Seth was saying about retrofitting security, like I think if you start dirty with too much stuff, you're going to really struggle to manage it over time. And I think you'll have people who've done really well at implementing one piece of the architecture, and then another piece has just been like stuck in really fast, quick and dirty, just because they needed it. And it's about designing something that's manageable for your team size, your company's needs, and actually keeping it pretty minimal. Like, if you can keep within, keeps as many different products like within like your cloud provider, that's probably a good idea. That's like one of the reasons that we're on like every cloud marketplace possible, just to make things easier for people, so they're not having to like manage different pieces of software here, there, and everywhere. We want to people are really sick of that complexity, because if you just keep managing that complexity, you don't really, that's a massive overhead that reduces your output of useful things and valuable things for your organization.
Sure. So avoiding a data architecture jalopy, so to speak, getting things simpler. May, any thoughts from you?
Yes, I think keeping it open is really important for folks. So you don't want to lock yourself into a architecture where if you change your mind or better technology come along, you cannot change it, right? So you are building a monolith. So we've been doing microservices for many years now. So we want to make sure that the architecture needs to be very flexible and very open, so that if anything changes, it's very agile. You can switch things out, switch things in. So I think that's really important, and also being very consistent. So don't let your engineers or anybody go out and build a bunch of in-house tools that you cannot use, I guess, like only that person can use. So it needs to be scalable. You need some kind of need some kind of a tool that everybody is able to pick up and start using, and not a like really complicated monolith that somebody just had fun with, build it out, so the next person come in have no idea what's in there, right? So that's incredibly important, is that build an architecture that's very agile and be able to go, anybody that can come in is able to manage it and extend it, etc. Yeah.
No fiefdoms and silos. Yes. Seth, what about you?
I think it's really important to consider, much to David's point, what do you actually need versus what do you think you might potentially need in the future. I think there are a lot of teams that think, we're going to be the next Facebook, Instagram, Twitter, X now, I guess. But today they have 100 users. And it's great to be forward thinking in terms of how can we evolve as our customer base changes, as our data volumes evolve, but also what's going to make you productive today. What is pragmatic for your business in this moment, and then leaving yourself the room to change that as the circumstances change. I also think organizations, this is not an original thought, but your software architecture internally is going to very much mirror your organizational architecture, and that is something that always feels self-evident after the fact. But looking around at the beginning and saying, do we like our team structure? Does this make sense? We know that these two teams are going to be building their own stacks. Is that okay? Maybe it is. Maybe they're sufficiently independent that they need that flexibility, but maybe they should be one team. Or maybe there should be some sort of bridge between them where they build on common foundations such that they can share infrastructure, easily share data, and interoperate as needed.
Understood. Matt, how about you? Anything you'd like to add?
I think I'm just going to reiterate some of my points, but one of the most important things when it comes to architecture, and I think May touched on this a little bit, is accessibility and self-service. Like, how much training is going to be involved to get a data engineer like new to your organization started before a useful query can be run, right? So one of the things that Couchbase we're doing, this is just one of the many things that could be done, right, is we're bringing SQL to JSON data. And that lowers the learning curve, because SQL is something that someone can use with Oracle, and they can take that knowledge and go to Couchbase, they can go to Postgres, go to SQLite, and so on. And so that lowers the learning curve of writing quality queries on flexible data, and it's just one other way you can get to value faster, right? But I think scale and performance was something that was brought up as well. As demands increase, can the tooling keep up? Certainly cost is a big one as well. So data sprawl has many costs, right? And often that data sprawl, that jalopy, grows out of necessity, right, with a piecemeal approach. But reducing that or preventing that from happening in the first place can make it much easier to get those insights through normal data engineering. Let's call it normal data engineering, and then more so with the AI and LLM enhanced analytics that are happening and will happen in the future.
Absolutely. So just like that, we are at the top of the hour, but before we conclude here today, and thank you everyone in attendance for staying with us past the bell, one more question from me to our speakers who we appreciate coming on board today. If there's one thing, and David, we'll start with you, one thing you'd really like our attendees today to walk away keeping in mind, what would that be?
Yeah, and I think I've seen some of this in the questions. I don't think that this wave of AI is a fad. I don't think it's going to disappear. I see it as the next wave that's like cloud. And we were just talking about how many of our customers are on cloud. All of them are on cloud, right? And I think AI is going to be used by most organizations around the world in pretty short order. And, it's not, I would stop kind of questioning, do I need to be concerned about it? And just think about how you can be prepared for it, and how can you make it available and usable for your company, and like, what are the things that you need to do for preparedness? If one of your stakeholders says to you, I want you to implement this, do you have that business case in mind of what are the steps that in data engineering that I need to do to get our organization prepared for it? Whether that's, pipelines, data warehouse, semantic layer, whatever it is, have you got those in mind and are ready to pitch it?
Understood. May, how about you?
And I think I agree with what Dave is saying, is that I think there is for AI in general, what we're doing with AI is that there's use cases, focus on use cases and value. So that's basically what we need to do, is focus on use cases and value. And for us is that we see use cases for data engineering is Copilot is that can provide a lot of value to that use case. But I think folks are still in the process of discovering what kind of use cases they have or what kind of value they have. So there's a lot of potential. But that being said, I think Seth made a really good point as well, that there's a lot of time. If you look at like how long it took Waymo to be able to drive in San Francisco. It's like 20 years from Stanley. So I think there's a lot of time that needs to be put into this process, AI in general. And I think it requires a lot of smart people to come up with even more new ideas to how to utilize it. And it might be tomorrow. It might be a year from now. I'm not sure. Probably not going to be me. So, but it's going to be somebody that's going to come up with something new and exciting. And I'm really looking forward to that. Yeah.
That's a great point, May. Seth, how about you? One thing you'd really like our attendees to walk away with today?
be thoughtful. I think all of these new technologies are really interesting. I agree that I don't think AI is a fad. I do think we're maybe in the middle of a hype peak, and I don't like it's not going away. I do think there's a lot of people out there trying to promote things, specific things that might not exist in a year or in 5 years. People are trying to figure out where this makes the most sense within an organization. I'm sure there's a place for it. Within any company, there's going to be a place for AI, for LLMs. And just, don't throw it at every problem. Think about, does it make sense here? Is this something you're willing to stand behind? Do you have the right foundations in place with your basic data architecture? And make sure that when you do use it, you feel good about that choice and that you're able to stand behind it.
Great advice. Matt, I'm going to leave you with the last word.
Oh, that's a lot of pressure. But yeah, I just want to echo kind of some of the same points. AI, I think, can bring a lot of value. But data sprawl, the data jalopy, as I like to call it now, it's one of my new favorite things to say, but it makes it very hard. So you need a good foundation of performance, low complexity, but yet flexible data to build something more than just like the hello world RAG type adaptive applications of the future. So I would say make sure that that effort of reducing complexity is part of your plan, and that's going to bring benefits to you beyond just AI use cases. So it's going to be worth it in the end, no matter if AI is a fad or not.
Understood. Well, I would like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, David Jayatilaka, VP of AI at Cube, Mei Long, founding member, product at Prophecy, Seth Wiseman, Director of Field Engineering at Materialize, and Matthew Groves, DevRel Engineer at Couchbase. If you in attendance would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. This will be archived, and you will receive an email once the archive is posted, likely tomorrow afternoon. And if you would like a PDF of the deck, you can go to the handouts section on the console once the recording is live on dbta.com. Also, just for participating in today's event, you could win a $100 Amazon gift card. The winner will be announced tomorrow. We'll let you know if you're the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.